given the polynomial function f of x equals x plus 4 times x minus 1 times x minus 3, find part A, the zeros, also called the roots of the function f, the part B, the factors of f, part C, the x-intercept on the graph of y equals f of x, and part D, the solutions of f of x equals 0. Part A, the zeros in the polynomial, well, it's just the values that are being subtracted from the x's. So for the first factor, x plus 4, what is being subtracted from x is the first root, or the first zero, in other words. So what is being subtracted from x in x plus 4? It's negative 4 that's being subtracted, because x minus a minus 4 is the same as x plus 4. In the second factor, x minus 1, the zero, or the root, is a number being subtracted. It's equal to 1. And in the last one, it's a 3 that's being subtracted. So the roots, or the zeros, of this polynomial are negative 4, 1, and 3. Part B, what are the factors? Well, the factors are x minus the zeros of the polynomial. Well, you can see them right there, but if we didn't know what they were, we've got our zeros now, so we could actually create the factors from x minus the first zero, comma, x minus the second zero, comma, x minus the third zero. Simplify, and our factors are x plus 4, x minus 1, and x minus 3. Part C, what are the x-intercepts on the graph? Well, the x-intercepts are the ordered pair xy that are equal to the zeros of the polynomial, comma, and 0 for the y position. So take each of your zeros, make them the x coordinate, and then plug the 0 in for the y coordinate. It's easier to call them roots than zeros because it gets confusing when I talk about the number 0, so I'll mostly talk about them as roots. So we have negative 4, comma 0, and the root 1, comma 0, and the root 3, comma 0. So there are our x-intercepts on the graph. Part D, what's the solution, or what are the solutions of setting the polynomial f of x equal to 0? Well, it's easy to answer because, see, the f of x is equal to the factored form of x plus 4 times x minus 1 times x minus 3. You just set each of those factors equal to 0 and solve, and you get your roots, or your zeros, negative 4, 1, and 3. Those are the x values that satisfy the equation f of x equals 0. And by the way, I want to add that we could get information from this problem to do the graph. If we graphed the polynomial f of x equals x plus 4, parenthesis, x minus 1, parenthesis, x plus minus 3, parenthesis, we could verify the answer that of the roots, what the roots are. They're the x values in the x-intercept of the graph of y equals this polynomial f of x. So you would see, if we graphed it on a graphing calculator, we're going to cross the x-axis or kiss it at negative 4, 1, and 3. And our graph would actually look like this. See, so that picture would just verify that we have the correct answers here.